G'day guys, welcome to RTRC. So, it's actually a fairly long time since I did a video, and I guess most of the reason for that is simply because I have been so busy. I'm sure for those of you guys who follow this channel, you're probably well aware I'm very deeply involved in the whole Rotorflight project, and quite simply I'm spending my life just coding and working and flying helis and doing all sorts of stuff, and it's a lot of fun. But I kind of just wanted to give you a little bit of a general what's going on, what's happening in the world of RTRC, and show you a few kind of cool things at the same time. So rather than being a dedicated video on one topic, this is a bit of an everything. So to start with, what's new? Well, the 007 Rotorflight controller by Frsky, and this is actually pretty fantastic. So I happen to have one over here, and well, you can see it's all shiny and silver. This is actually not the final colour they're coming out on. This is a pre-production test unit that I've got, and I've actually got the older test unit here too, which is in the colour they are coming in. And kind of really just a little bit of a background to this. So as part of the Rotorflight project, I've been working with the guys in Frsky USA and some of the chaps over in China, and essentially the whole aim was to bring out a Rotorflight controller that had a Frsky receiver built into it. And this is really just to provide an option, because if I get my radio here, look, good old X20 Pro here, and Rfsuite runs on that, and in the end what we actually want is a controller that seamlessly integrates with everything pretty much that Ethos has to offer. So along came the 007, and it took a while, and for those of you who follow again, you might have noticed somewhere along the line we had FBus support arrive in Rotorflight, and this was quite a lengthy process, because to all intents, FBus is not actually an open source protocol. It's a protocol which we went through great lengths to get Frsky on board with us putting the code into Rotorflight. And this was very important, because we wanted to ensure that whatever we put in was actually correct. It had to just 100% work. So, we didn't have to start from nothing, which was great, because I never really had a whole lot of stuff ported across, but it was a little bit incomplete. And the end result to all of this is that I did an initial port of the INF code, and then along with Frsky, we then had one of our other developers look at it, and we enhanced it and improved it to the point where FBus worked perfectly, and then Frsky signed it off. And that's brilliant, because what we actually got at that point was your code is correct, and that nothing that they do on their side is going to break what we've done. Because you know what, at the end of the day, we're flying big expensive machines which can potentially kill you. Your control link is important, so we've ticked all those boxes, and that was utterly key. And then off the back of that, and all the initial discussions was, well, let's get a controller built. And it actually surprisingly hasn't taken that long. It feels like a long time when you're so bedded into it, but I don't think it really took more than 3 months from beginning to end. And Frsky had a controller which they built to the specifications of the Rotorflight project. For your reference, there's basically Petri, Dr. Rudder on Rotorflight has created a series of reference designs, and any manufacturer out there can use these reference designs, and we chose one to use on the Frsky project, and away it went. And Keith over in the US, some of you might know him as Blade Scraper, he's been working very hard on the Frsky front, working from that angle. I've been worrying about the Rotorflight side, and great things have happened. So there you go. We have a controller. Now, the first thing that's going to jump out, and everyone's going to go, what does it do that the Radio Master Nexus doesn't do? And the simple answer is it does everything the same. It's Rotorflight. It really, a controller is a controller is a controller. Really, there are better ones, there are worse ones. They all do the same job. But yeah, kind of the biggest difference is ultimately there is a receiver built into it, and that's kind of important. So Frsky are selling these with two controllers, or two receivers. There's an Archer version, which will work with all of your multi-protocol modules. It will work with any of the older Frsky radios, and then they've also got the twin version, which will work with all the newer radios. So two different versions of this on the market, different receiver, exactly the same thing, just a different receiver built in. Now, next thing, beyond it being much the same, ports. All of these ports, whether you're using a Nexus or a 007, they are standard. The pin positions are standard across everything. That is the whole point of the reference design. What that means is that if you've got a Nexus, for example, already wired in, you can just get the lead, plug it straight into one of these, it will work. And that's very important because we don't want people blowing stuff up because different manufacturers do different things. So that's kind of cool. What else does it have? It comes with F-bus built in. No, literally out the box you could plug this in and literally almost configure your entire heli from the Ethos radio. That's not going to be too far off in the distant future. But yeah, then beyond that, we have, compared to the Nexus, and I'm going to give you a quick example. That's the Nexus, that's the 007. There is definitely a size difference to these. And the first thing everyone's going to go, oh, the Nexus is smaller, this is bigger. Why? Well, it really is as simple as the fact there's a couple more pins on it. You've got, so for example, on the Radio Master over here, you can see I've got to lift my glasses up so I can see. We have 1, 2, 3, 4, 5, 6, 7 pins. This, I believe, has 9. And that opens up possibilities to do other things. Essentially, it gives you, for example, there's a dedicated port available for S-bus out. So for people who happen to want to use S-bus servos, scale guys might want to run multiple things, you can configure one of the ports to be S-bus out. It doesn't have to be that. It could also be an input port, because in the end, it's just another aux port. You've also got a dedicated auxiliary port, and you've got a dedicated telemetry port designed for your speed controller telemetry. So you have a little bit more scope to kind of plug stuff in. Unlike the Nexus, so that's your Nexus with all the pins, you also have a jack on the top over here. That jack basically allows you to put up to a 12S battery into it by memory. I think it's up to 60 something volts or something can go into it. But essentially it means that if you do not have speed controller telemetry and you want to measure your battery pack voltage, you can literally tap it on there. Internally there's a voltage divider. Job done, it will give you the reading in Rotorflight. So very useful. For those of you who have spotted, there's also a port on the side over here. That port is a receiver upgrade port. It effectively piggybacks straight onto the back of the pins on the receiver, and it's designed for doing firmware upgrades. That's what its purpose is for. Of course, depends again, because if you're using your radio, you can do this over the air, but you know what? Sometimes things go wrong, so you flash the wrong firmware wirelessly over there. Could happen. You broke it, well, you can plug a cable in and you can still flash it. You don't have to open the whole thing up. So, yeah, all up, it is a great little unit, and, I've got a number of these on the way, and I'm going to be plugging them in because I do fly exclusively with Frsky. I do have, on the back of my radio, I've got an ELRS module, but actually, I've only got one ELRS receiver, and that's in the OMP heli that I've got. So, yeah, one of those things. Well, these are great systems, and I'm very chuffed. Now, as we're on the Rotorflight topic, I thought I would show you some cool stuff which is coming for Rotorflight 2.2. Now, this is sometime in, well, it's not even sometime in the future, a few months away maybe, give or take, but this is very much for you guys who use Rfsuite and are interested in it. So there's a couple of things I want to show you. And first thing I'm going to do is give a big shout out to Lucas from Discord, because he's done some fantastic integration into Visual Studio Code, which I've got here. And you can actually see if I now start running and click Start Debug on my screen, it loads, gives me a full debug over here, and actually prints out lots and lots of information. And I can then obviously sit and run through and do stuff and see what's going on. So Lucas did all this integration a matter of days ago, and it is fantastic. It's really sped up the development. But yeah, so where are we at? Things I wanted to show you, because I'm sure some of you might have seen it, some of you might not have, but we'll show you in the simulator anyway. So, big changes. The status widget has had a few minor changes, largely little things like this notification saying missing required sensors. What this is actually telling us is that the receiver is not sending the sensors that the suite expects to be there. And the only reason you're going to have that happen is if you haven't configured them on your flybarless unit. So it's really just telling you what's going on. And what's kind of cool about that feature is that if I go into the Rotorflight suite, what I can actually do is go all the way down to sensors, and I get a list telling me what is or isn't okay, and whether things are good, bad, etc. So these are kind of, this is all in simulation mode at the moment, but you get the idea. It kind of shows you what is or isn't there and what is or isn't valid, so you can actually go away and fix the problem. The great thing is this name is also exactly what the sensor is called in the Rotorflight page, you know, in the config tool, so it kind of makes life easy all round. What other features do we have in this suite? Crikey, it's a while since I looked at the base one, but let me run through this. We have new things which you probably haven't seen. We've got motors. All of the gear ratios, pinions, all this sort of stuff can now be edited and configured. That's kind of cool. We've got S-Bus output. If you had an S-Bus output port like on the 007, and you had also configured your serial port and your hardware to be an S-Bus out, then this menu will work, and you can see it gives you 16 channels, and each channel you can go through and configure. Now, this is rather complicated in some ways, but you can basically say what you are outputting to, and where the source signal comes from. And I actually need to write some documentation for this. I've got some basic stuff over here, but essentially you can sit and map where the channel source comes from. So for in this case, okay, we're doing a mixer one, what is the source channel between 1 and 6, or 0 and 15 actually, and then what are the values, and a bit of experimentation. It's basically enables you to mix and match almost anything. You know, you can take the output from a motor and map it to a channel, you know, so motor 1 would be mapping to a channel out in a different, you know, it's all very, it's very complicated, but it can all be configured, which is kind of cool. What else do we have? I think radio config. This never used to be there. You can edit all the stick positions and centers and things like that, which is cool. You know, I've deliberately not put a drop-down box in for configuring your radio type. You know, I've had a lot of thoughts on this, but what really worries me is that if you set the different receiver, you know, and said, oh, I'm going to set my protocol to be, say, X-Bus. Brilliant, you set the protocol to do that, but all of a sudden you've just locked yourself out and you're going to have to plug in the configurator to fix it. So I've intentionally hidden certain things like that. But you can go in and edit them. We've got things like the battery can now be configured. So all of the battery parameters, the milliamp hours, you know, cell count, all those settings that you can do in the configurator can be done on this. Let's see what else. I've already shown you sensors. You'll actually notice over here, these are some developer options, which actually enable you to do some interesting stuff where you can run a speed test, and it will actually query, I'll close that, it actually queries the bandwidth between the flybarless unit and your radio to performance test your stuff. But those are not actually enabled by default, but they can be turned on in the config file if you wanted to. You know, what else? Oh, logs. Logs is a big one because you probably haven't had logs before. So what actually happens in the suite nowadays, everything I'm sure you guys have seen before, there's a background task that has to be enabled. And if we were to look at the Lua and you saw the background task, one of the things that task is doing is monitoring when your heli actually gets armed. And that's why you have things like the missing required sensors, because if it's not detecting the armed value, then things are just not going to work as you expect. So essentially what it does is it will detect when you arm and it will start to log stuff. And you obviously notice I went into the logs tool earlier from here, but I can also go and direct from here. The reason there is a separate icon for it is, well, number one, for speed, because people do it, but the other thing is that this log will work without being connected to the heli, whereas the configuration tool does not work unless you are connected to the heli. So you can look at this offline, which is kind of cool. But if we took a look here, what ends up happening is the radio will pick up the details of the heli that you got, either the name of the model memory or the craft name that was set on the heli, and it will create a log file. And this is my R42, one of the more recent flights. And if I open that up, we get a whole lot of information, which is kind of cool. So minimum, maximum voltages, maximum current draw, maximum head speed, temperatures, etc., and the throttle position. And you can see over here, we can have a good look at the duration of the flight and all the values that were there on the way. And for me personally, probably the most useful feature on this. In fact, actually, it's kind of interesting here to see that the ESC temperature jumped shortly after I landed. And that's curious, because what that means is that I landed and then there was no cooling from the rotor blade, so you saw the temperature go up. And that's kind of interesting. But what I find probably the most useful feature is the throttle percentage. And seeing that value being quite high, like what is that percentage? So 79% max, so it's averaged around there. That's obviously going up and down with the governor. That's kind of expected, but it does give me an indication whether or not my system is going to be close to bogging down while I'm flying. Because, you know, if my speed controller was sitting at 100% output in order to kind of deliver the power that I needed for the head speed, well, I got a problem. It's as simple as that. So I'm kind of about right. I'm on the 70 to 80% mark on this particular heli. But yeah, that's kind of cool. It's a whole log. It's all in date order. You know, there's lots and lots in here, and you can see I've done lots of flights with different helis, and I'm kind of chuffed with this. It works well. It really has proven to be quite a good tool. Then, what else has changed? Well, broadly within Rotorflight, there's been well, on the suite anyway, there's been a lot of code changes. It might look the same to you, but it's not. You know, a lot of the features that have been built in have been literally, I've rewritten them from the ground up to make things a lot more dynamic. And, you know, whilst you don't necessarily see the benefit to that, I certainly do, because it makes it easier for me to maintain the code. And it's kind of enabled some cool extra things to be done. So with dynamic code, which just picks up what's there in your environment, for example, and I'll show you over here, if I open up another screen, it's enabled creation of additional widgets, which just automatically appear. So we have craft image, we've got craft name. These are actually very similar. But you'll see this one's got a name and an image, but if I go in and configure it, I can turn the image off and set the font sizes and things. Did that go? I don't know. I think I might have to go on and off that page to see it. Oh, do I have a bug? I've got a bug. Image is on, image is off. Oh, no, it is. I must have just turned it on. I did something wrong. My fault. But yeah, essentially you've got the ability to get the name. Now, that name comes directly from the remote heli. So on the configurator within Rotorflight, you can set the craft name. You know, so if I had a heli and I called it OMP, I would have OMP written there. And that means you can start doing customized Customize displays, because there seems to be a large number of people who want to use one model memory and have that one model memory pretty much do everything for them. And this gives you that ability to have a custom name and a custom image. And oddly, that functionality is actually also built into the suite with this particular widget, the status widget, because I can go in my display announcement, or the customized display, and we have a craft name somewhere in here. Oh, where is it? There is a craft name. And I think, well, craft image we've already got. It's just called image. So craft name will give the name, and image does the same thing over here where it will pick up and use the image. Now, the image actually comes in dynamically. And what this means is it will use first and foremost the image that you've assigned to the model. However, if it receives the model ID parameter of the flybarless unit, it will then look inside the folder on the SD card and say, do I have an image that matches that name? And if it finds the image, it will then use that image. So the result is you can get custom images and custom names and things appearing on your screen, so you know which heli you're connected to, which is kind of cool. What else? Oh, code-wise, let me close that off. I've written a completely new API system. I kind of wanted to abstract a lot of stuff within how I interact with the flybarless unit remotely, and we can actually see a little bit of the code here. And what I've done is, rather than having to drive and draw up information in terms of this is what the packets look like in terms of sending data to and from the flybarless unit, there's an abstracted API which says basically load the governor config API, and then I can read that particular value, and then when I issue the read command, it goes. So it's actually, you can see there's a set complete handler, so it basically takes that's applying the parameters, and then when read runs, fires off a connection to the flybarless unit and asynchronously comes back and populates that memory variable, which is kind of useful. But everything kind of gets abstracted, and I've got like governor profile as a classic example, and that's a little bit untidy over here. I can use one of these lovely features inside here. Please place all on one line. I wonder if that will work. Oh, multiple lines. I've done this wrong, you see. It's because I'm on a call and I've said one line, but please make readable on multiple lines. There you go. This is the great thing about modern coding environments. You've got so much interaction like that where you can tell it, there you go, look at that. So, kind of what I wanted to show you was that with the API that we now have, is we've got a whole lot of things. It's like, for example, that's the value of the function on the flybarless unit I'm reading, that's the one when I write to it, and I define data types and structures which match. And it just means if I said I wanted to get that value, for example, I can say load API governor profile, get value this, boom, and it appears. And then if I wanted to write the value, I could say load API, pre-populate the data, and I can write the value back. So it's kind of cool. So every single MSP call that we currently use has been ported over to this, and I'm kind of chuffed it works. So yeah, what else? I don't know. I don't know if there's anything more I can ramble on to you about, but it's all exciting times. There's a lot of cool things happening. I'm looking forward to the next release of Rotorflight. It certainly kept myself and the rest of the guys who are working on it very, very busy. In the pipeline, we've got XDFly speed controller support coming. We've got Escape 32 support coming. There's just lots and lots of new and very cool features to it. Well, hopefully be there by April, May area before the flying season starts. So it's all good stuff. Anyway, guys, that's me. I've rambled on probably for 25 minutes or something silly like that. So somehow I've got to upload this all to YouTube. Hope you enjoyed it. Hope you are maybe going to go out and try one of these 007 controllers, because I'm very chuffed with them. They work well. And yeah, enjoy. Happy flying.